My name is Lowell Iporak, and I am a recent PhD graduate from Florida International University in Miami, Florida. My dissertation research specializes in marine macroalgae as habitat for small invertebrates. I am also the founder of the Sargassum Watch citizen science program developed using the EpiCollect 5 app. I want to share with you all today a story of a seaweed bloom that's ongoing in the tropical Atlantic. Historically, a golden brown seaweed called pelagic sargasso is found northward in the Atlantic Ocean in an area called the Sargasso Sea. Usually, large floating mats of sargasso provides habitat for marine life such that it is also called a golden rainforest. A series of oceanographic factors around 2009-2010, such as changes in wind and water currents, combined with nutrient outputs from various sources, brought to life a second source of sargasso. In an oceanic area between Brazil and West Africa lies a developing second source and currently one of the largest seaweed blooms in the world to ever be recorded, called the Great Atlantic Sargasso Belt. Since 2011, massive influxes of this macroalgae were washed up on beaches from the eastern Caribbean islands to the Mexican Caribbean, from southeast Florida to West Africa. Imagine a beach in Cancun, Mexico, a hot tourist spot in the Mexican Caribbean, piled kilometer to kilometer of this golden brown to black seaweed, smelling of rotten eggs. Off to the water, dead fish and other marine life were strewn along with the seaweed. It's not the fault of the Sargasso algae, as it's not an inherently harmful seaweed. Rather, it's the process of accumulation and decomposition, of which the latter process uses up oxygen in the water column, suffocating marine life in adjacent seagrass bed and coral reefs. This was a common theme during the summer months, when Sargasso influxes are at its peak. During the peak season, usually from March to August, Sargassum from the Great Atlantic Sargassum Belt gets transported through wind and water currents across the West Tropical Atlantic and landed at various beaches across the region with varying degrees of severity. I started my PhD in 2016, 5 years after the first major reports of Sargassum influxes, but it wasn't until 2 years later when my graduate advisor exposed me to the landings at South Florida's beaches. I've always had an interest in getting the broader community involved in the process of science. Right then and there, I decided on creating a citizen science program for monitoring the Sargassum influxes in the Caribbean. The Sargassum Watch program is made by the free open source app called EpiCollect 5, developed by the Imperial College of London in the UK. With the help of local community members in South Florida and by outreaching to other community members across the Caribbean, our network were able to detect and collect photographs of Sargasso inundated beaches and a close up of the seaweeds. These photos were then examined to classify the level of accumulation and the species of Sargasso present. Oh yeah, did you know that there are two species of Sargasso, Sargassum natans and Sargassum fluitans? And within the two species, you can have different forms as morphotypes, which are dependent on shape, and I guess molecular evidence as well, but we're not going to get into that. Sargassum natans can occur as Sargassum natans 1 and Sargassum natans 8, while Sargassum fluitans 3 has a single morphotype that's very abundant called Sargassum fluitans 3. Why mention these morphotypes? It turns out that different compositions or morphotypes can tell us something about where the Sargasso algae came from. Did Atlantic Sargassum came from the Sargasso Sea or the Great Atlantic Sargassum Belt? Monitoring efforts from quadrants to drones to satellite imagery can help put these different scales together about where the sargassum is coming from, how it moves, and where it lands. The citizen science program helps by collecting a series of data per observation, which usually lasts a minute or two per volunteer. The data then gets uploaded onto an open source database where stakeholders such as government agencies, academics, and private entities can use the data as they see fit. For instance, my former team, consisting of undergraduate and postgraduate volunteers led by me, categorized the photos based on a numbering system and marked the presence of morphotypes. Our work, now published in Aquatic Botany, showed how citizen observations from 2019 to 2021 are actually very consistent with satellite imagery. A low budget citizen science program ground-truthing high-tech satellite imagery models. Very nice comparison, if you ask me. The Sargassum Watch program, which started as a graduate research project, is gaining relevance to the scientific and professional community interested with sargassum. After finishing my PhD this year, I am faced with a challenge on continuing the project as an independent initiative. Currently, the project is run unpaid and entirely through volunteers, including the inner team. Keeping track of volunteer data collectors on ground and ensuring that their work and collaboration are mutually beneficial between us is something that we want to enhance as a next step. So, if you're a volunteer who has helped out with monitoring previously, we want to express our thanks and gratitude and hope that you'll continue volunteering with us. If you aren't based in Florida, the Gulf of Mexico, West Africa, or the Caribbean and would like to help, our website in the description below has the protocols in PDF and video format. As for other listeners who are looking to help the Sargassum Watch project in other ways, either financially, academically, or through other means, feel free to reach out to us. We'd be interested in however you'd like to contribute. Sargassum influxes seem to be a very dynamic phenomenon happening every year, and it doesn't seem to be disappearing anytime soon. Thank you for listening, and see you next time.